Welcome, 8th graders. This is Mrs. Minowitz, and I'm going to be talking about minerals today. So, the first thing that you need to know about minerals is that they are pure substances. And if something is a pure substance, we already know that means that it is an element or a compound. And the difference between rocks and minerals is that rocks are mixtures, and rocks are actually mixtures of minerals. So, when you have different minerals put together, that makes up a rock. There are 5 characteristics that minerals have. The first is that they are naturally occurring, which means that they're found in nature. The second is that they are inorganic. That means they're not living or and they don't come from something that is living. Um, it says mostly here because there's an exception made sometimes for coal. Coal would be considered organic. It comes from something that's living, but many scientists would still consider it to be a mineral. All of your minerals are going to be solids. Okay. They have something called a crystalline structure. So that means if you look at how their molecules or their atoms are arranged, you see some different patterns with that. We've got examples here of graphite. Graphite is made of carbon. It's found in your pencil. And you can see it's got kind of some nice, even, flat sheet type structure. Diamond is also made of carbon. But instead, if you look at its structure, it's very different. Again, still a crystalline structure, but graphite and diamond have very different properties, even though they're both made out of carbon. Um, Minerals also have a unique chemical composition. This means, again, that they are either elements or compounds, and that you could also write out the chemical formula for them. For example, NaCl is a unique chemical composition. It's got sodium, chlorine, um, and it's different than other elements or compounds. That's a unique chemical composition. We're also going to be looking at how you can classify or group minerals. There are over 3,000 different types of minerals, so they needed to find a way to put them into different groups that made sense. So the most common one is called the Dana system, and it divides them into 8 basic groups based on those different chemical compositions. The most common minerals are called silicates. They contain both silicon and oxygen, and quartz is a pretty common example. It's silicon dioxide. Here's that unique chemical composition. Um, they make up the most minerals. I believe about 90% of minerals are silicates. And then there are some other different classes or groups depending on what they're made of. Carbonates contain carbon and oxygen, and a common example is calcite. We're not going to go through all of these different types, and I don't expect you to know all the different classes of minerals, but do know that they are grouped by their chemical composition. One we are going to talk about are called native elements, and these are minerals that are also elements. And some examples would be nickel, aluminum, copper, gold, silver, iron. Those are all examples of minerals that are also elements. One of the things that we are going to be doing in class is looking at how do you identify minerals. How can you tell them apart from each other? So in order to do that, we use different tests of physical properties to tell different minerals apart. And there are 7 different tests that we are going to talk about, or 7 different things that we're going to talk about using to identify minerals. The first one is called hardness, and this is how easily a mineral can be scratched. It does not mean how easily that mineral can be broken. We're not looking at breaking minerals here, we're just looking at scratching them. So in order to tell the hardness of a mineral, there's something called the Mohs scale of hardness, and it rates their hardness between a 1 and a 10. So on your screen, you have the 10 minerals in the Mohs scale, ranging from talc, which is really, really soft, means it can be scratched by everything else on here. And then the hardest mineral on here would be diamond. It can scratch everything else on here. So diamond can scratch corundum, topaz, quartz, feldspar, apatite, fluorite, calcite, gypsum, and talc. So if it has a smaller number, it can get scratched by a larger number. If it has a larger number, it scratches a smaller number. Now, normally when we go around testing this, we don't always use mineral samples, our reference minerals. Instead, in class, we have other things we can use, such as our fingernails, or pennies, glass, streak plate to compare the hardness of them as well. Another property that can be used to identify minerals is what's called luster. And luster describes how light is reflected from a mineral's surface. So you're looking at the surface of the mineral and deciding if it's metallic or non-metallic. And if you think about the names, metallic, okay, looks kind of like a metal. It's very shiny and it reflects light, versus a non-metallic mineral which does not look like a metal and has more of a dull surface or a glassy surface and does not reflect as well as the metallic surface. The third property that we are going to look at for identifying minerals is color. So color, pretty straightforward, what color you see when you look at the mineral. And this is the least accurate property for mineral identification. And there are two reasons for this. The first is that there are some minerals that can be many different colors. Quartz, for example, has multiple colors that you can find samples that are white, pink, purple. So it's not always easy to tell exactly what it is based off the color. The other reason is that there are lots of minerals that have the same color. If I tell you that a mineral is white, that's not super helpful usually because there's a lot of minerals that are white in color. The fourth property is streak, and streak is the color of the mineral when it's broken up. How you test this is you scratch a mineral across what's called a streak plate, and the color left behind is the streak. This only works if the mineral is softer than the streak plate, and a streak plate has a hardness of 7. So if your mineral has a hardness of 9, it's not going to have a streak because the streak plate can't scratch it. So if you look here, we've got a couple different samples. Looking at hematite is this brownish red streak over here. Sometimes you can have other colors, white, dark, and everything in between for your streak. The fifth property that we're going to be using is how a mineral breaks. So if a mineral breaks with fracture, it has rough, jagged edges. They are not smooth. And then cleavage breaks into smooth, flat surfaces. So if you take a look at these pictures here, on the left we have a mineral that breaks with cleavage. You'll see it has like the nice corner here, flat, very flat surfaces when it's broken. The mineral on the right is sulfur, and as you can see, there are not those nice flat surfaces when it breaks. It's got those rough, jagged edges. It's not very smooth when it breaks. The sixth thing we are going to look at is some unique properties of minerals. So there are two minerals that have some very unique properties. There are others as well, but these are two that I would expect you to know. The first one is magnetite. This mineral is magnetic. So when you hold it up against something else that is magnetic, it will be drawn towards it. The other is calcite. Calcite fizzes when hydrochloric acid is placed on it. So it'll have little bubbles when you put hydrochloric acid on it. The seventh property of minerals that we're going to look at is density. We've already talked about density this year. Density, if you recall, is calculated by taking a mass and dividing it by volume. And density is a property of a mineral. So that means if you have different samples of the same mineral, the density will always be the same. So if I have 4 samples of quartz, even if they're different shapes and sizes, that density will be constant. It stays the same because it's made out of the same material. Just like the density of water is always 1, the density of the same mineral will always be the same. Thanks for tuning in with minerals.